So we stopped at, well, last lecture, last 5 minutes, we started discussing arrays. One thing I told you is that in some of the standards, some of the C standards, for example, in C99, the most recent ones, C99 and C11, they do allow the size of the array to be a variable. So we said that's okay. And we, in fact, had an example that uses this, which is the reverse function. But we said basically just don't do it, right? So usually my approach in C, especially in C++, is that if you can be standard agnostic, which means you write code that combines for any compiler, you should do it, right? So basically this is allowed. It's allowed in the course. You are not going to be penalized for using it. But as a good programming practice, don't really use a variable as the size of your array, right? What you should do instead is use the define, which is a symbolic constant that the preprocessor basically, we discussed last time that the preprocessor will go through your code, remove any size here, for example, and replace it with 10. Good? This is allowed in any C standard, so it should be a safer way of doing it. Good. Then we have went through all of this. Last time we stopped at the reverse example function. We have went through initializations as well. Oh, by the way, one thing related to initializations, and I might have already mentioned this at the last lecture, but just to confirm, we said arrays, unlike variables, are initialized to 0 by default, correct? If you recall this. But then we also said some of the compilers might not be doing it. And it turns out that Eclipse, in fact, does not initialize arrays by default to 0, which is too bad. But again, as a good programming practice, if you initialize all your arrays to 0 by default, then it's just a safe side, right? Good. And one way of really initializing an array, because you might say, if I have a million element array, should I write a for loop, or what should I do to initialize it? So in fact, and well, I have a good surprising news to you is that I finally got my pen working. So so if I write something like this, and let's say I have a million here, it doesn't really matter what is the size, right? As far as it's a legal size. To initialize all the elements to 0, it's just enough to write this. And you might have already seen this in the test cases that we provide to you, right? If you do this, well, do you recall what was the rule from last time? Is that if you initialize some of the elements and not the other elements, what would happen? Is that they will get initialized to 0 by default, right? So here I'm initializing the first element to 0, which means implicitly that all the other elements will be initialized to 0 as well. Good. So this is maybe the safest way to initialize arrays if you don't want them to be initialized to a certain value. Good. Okay, so what we stopped at last time is using this reverse function. And I told you it might be interesting if we code it together. So let's do this. So again, I will open online GDB. Might be good to have it as client. Get it a bit bigger. And let's just copy the example from here. Okay, so what are we doing in this main? So simply I'm initializing, I'm just defining an array that is double, that has 6 elements, and then I'm giving it some values. Good. And then I want to reverse this array. So I have a reverse function. This is the prototype of the function. What it has is that it takes 2 input parameters, my array and its size, and then it returns nothing. Why it returns nothing? While I really want to modify the array. Why this is okay? Yep. Yeah, exactly. Thank you. So basically, we said arrays are passed by reference by default, which means any writing you do for these arrays in the callee function will reflect in the caller. This is why we're just passing the array and we're returning nothing, because any modification to the array, as we will see right now, will reflect really on the main function. Good. And then after I reverse the array, now I'm abstracting that, assuming this function will reverse it, I don't care how, I'm printing it back. And once you print it, we should really see how it's also reversed. But then to be able to achieve this code, I need to implement my own function for reverse, right? So what I should do, I should just write my reverse code. So how to do this? Well, we have already done it before, right? Well, but we have done it before, in fact, to bring them in a reverse order. So we didn't in fact modify the array itself. And this might be the interesting part. So let's think a little bit. If I have an array of n elements, here it's 6, and I want to reverse the elements, which means I want the last one to be the first, the second last one to be the second, etc., etc. How can I do it? What do you think? What approach should I take? Yep. Good, good, good. So thank you. So this is in fact a good starting point. So a friend here said, well, you have a counter that starts from the end, but you want to take the last value, put it in the first value. But if you do this and you override the first value, you're going to lose it. So maybe you use a new array, right? So maybe you use a new array of the same size, have a for loop that takes the last, put it first, etc., right? Well, that's definitely a possible implementation, right? You see that implementation is simply I write a for loop here. Let's say something like this. And then I start from the last, just saying this is starting from 5 and it's larger than or equal to 0. And then should be I minus minus. Well, I should define I here. This is wrapped and I equals. Okay, and then what should I do inside? Let's first close the bracket. Your friend here said, well, you will take the last element. Here is X array I. And you would put it somewhere in another array. Let's call it Y array. It should be something here that I'm leaving. Well, what should be the index here for this Y array? So our algorithm, we said, we'll start from the last, take it and always put it in the first. You will end up with a new array that has it in reverse order. Yep. Great, thanks a lot. So what should I do here is initialize another variable, put it to 0, use it to index my array, and then inside my for loop, I would increment it. Because every time I want the last to be in the 0 and then 1, 2, 3, etc. Yeah. Great. So, well, this sounds like a good algorithm, but am I missing something here? Sorry, can you say this again? Yeah, you mean, yeah, oh, so okay, I see it. So basically what you are in the correct direction, but maybe you're using the wrong terminology. So what you are saying is that here I'm using an array called Y array without really saying what is the type of this array or anything, right? So in other words, I'm using an array without declaring it, which is not allowed in C, right? So what I should do instead is I should go here and declare Y array. What would be the type of Y array? Double. Because it's holding the values of X array, which is double. And then what would be the size of Y array? I don't hear. Yeah, please. Yeah. N, exactly. Thank you. Yeah. Why? Because here I'm taking n as a parameter, right? So while I'm allowing this function to really reverse array of any size, right? Please. Great. Yeah, you are correct. So instead, what should I do? Yeah, instead, what should I do? You highlighted something. Exactly. Thank you. So to be more generic, based on this function, it shouldn't be really just 6. It should just be n, right? Because I shouldn't be hard coding the size of the array based on the example I have in the main. I could have, in fact, defined another array in the main that has a size of 60 instead. But in that case, this function will not work correctly. So instead, I should start from n, which is the size of my array. Yeah. But should I start from n? N minus 1. Exactly. Thank you. Because we said basically n means if you have 6 elements, your last element will be 5, right? So if you have 100 elements, your last element would be 99. So if you have n elements, your last element would be n minus 1. Yeah, that's also a good question. So let's think about the following. So if I wrote something like this, what would be the first element I access in this xi array? And give it like a concrete example to make sure you are not confused. So assume n is 6. So basically X array 6, right? So you will try to access the 6th element of an array that only has elements up to 5. So that means this is still incorrect. You see the point? Right? Yeah, it's out of index, which is, well, the compiler will not complain, but you know that you are not out, you are out of your boundary of your array. Is that good so far? Exactly, thank you. So if I have done this and I run this code, let's see what happens. Well, I end up, what I'm doing right now, I'm really printing the elements. If you see, this is the printf we have here, which is printing the myArray elements. It starts from 1.1, 3.3, 9.7, etc. If you look here, well, they're not reversed. So why that's the case?
So you're storing the variable inside your function, but you can reference that in your variable.
Exactly, thank you. So basically what I'm doing right now is I'm using myArray to hold my new values, which are the reversed order. But then what? This is a local variable to the function reverse, and from our lifespan and scope lecture about variables, this variable will get destroyed once we go back from the reverse. So it's never accessible by main. If I want it to be accessible by main, what should I do? If basically I want to reflect the value back in the main and want this code to work correctly, what should I do? Well, that's a good point. Can I return y? We cannot return an array from a function. We said this before, right? Yeah, please. Yeah, correct. That's a valid way of implementing it. Instead of really defining or declaring y inside the reverse, declare it inside the main and then use it. But the problem with this is I will come to the raising hands. Let me just comment on this. So the problem with this is you are really making the callee function implementation dependent now, right? As we will come later on, this is not the most efficient way of implementing stuff. So if you do this, you are forcing the main. Well, in other words, assume that you are a user of my reverse function. I'm telling you, instead of passing me the array that you want to reverse, you are obligated to pass me another array. Well, this is a little bit counterintuitive, right? And so it's a correct way functionally, but it's not the best way. But I can do something different, please. Yeah, I believe what you're saying is that you want, after making y array, after basically building up your y array, you want to copy it back to the x array, right? So that's correct. And to be able to do this is I really need another for loop, correct? So I need another for loop that goes now in the correct order. And then what it does, it just simply copy back y x array I equal y array I, right? If you were in Python, well, you could have written something like this. X array equal y array. But that's not legal, right? We said we cannot use the array name as is as a variable, right? So this is not possible. And in fact, we should copy every single element to every single element. So an entry to an entry, a double to a double, right? Not an array to an array. And this is why we need this for loop. Good. So if we have done this, well, at the end of this function, now I have updated X array. So if I run it, you will end up with the elements reversed now. Good. Is there any question? Is that clear? Good. So if that's the case, well, this is a valid implementation, but in fact, it's not an efficient implementation. So why it's not an efficient implementation? Yeah. Oh, we did. You say we did not reverse the actual array? Yeah. And then copy it back. That's correct. So in other words, and you will learn more about this later on into SI and other courses, is that, well, there is something that is called time efficiency, and there's something that is called space efficiency. Yeah, but let me see first. Well, that's also another part of the not being very efficient, but that's not the main one. The main one is, in fact, is you are using, again, an auxiliary array. This is usually called an auxiliary space that maybe in fact not needed. What I mean is you need to reverse your X array, correct? But to be able to do this, you need to define another array of exactly the same size and only use it as a temp variable, right? So you are using as much memory as your X array. Assume, for example, your X array has 100 million elements, right? And you want to reverse those. Well, using another 100 million memory locations to do this doesn't seem very efficient. This is usually called space efficiency, where you need to take care of how much memory you need to allocate to conduct the algorithm you want to achieve, right? You see the point? So, well, but can I do something otherwise? Well, please. Yeah. Okay.
Change the first value of your array to the end value of the array itself, and then assign the temporary integer to the last instance.
Good. So you are in the right approach. So thank you. So basically, what your friend here is trying to achieve is what is called usually reverse in place or modify in place. Instead of defining another array where you can easily modify, and by the way, you'll find this a lot in interview questions, software interview questions. They restrict you on how much memory you can use because, well, this problem is not really very interesting if I can use another array. Just a couple of for loops, copy it here in reverse order, copy it back, right? But what might be interesting is that if you are prevented from using additional array, right? What can you do? So your friend here is thinking, well, what I want to do in this original array is take the first element, put it in last, and put the last, put it in first. And then take the second, put it in second last, right? So what I want to do is something visually like this. I want to do something like this. I want to take this element, put it here, and take one, put it here. And then take the second one, put it here, take this one, put it here, right? Etc. etc. So eventually you are swapping elements now, right? So if you assume that there is a swap function that takes the first, put it in last, and the other way around, then this function will mainly depend on a temp variable. Now we are using only a single integer for this, right? Or in this case, it's double because your values are double. And then you will keep doing it. Yeah, I guess there was a comment.
Oh, yeah.
Well, yeah, this is usually called the circular array, but this is an advanced, well, what you're assumed here is you want to reverse this static array elements without using pointers or anything, right? So that's, yeah, there are usually more advanced data structures to allow for easy reverse. But yeah, this is outside of the scope of this slide. Later on, we will revisit that. But you see simply what we want to do, right? So the algorithm is, I want basically to do this. So let's try to together think about this this algorithm. So again, simply if I'm doing that, how can I write more or less a flowchart or a pseudocode that achieves it? So your friend said, well, start from the first element, right? So simply you have a loop that starts from I0, and then we will come into its boundaries now, right? And then you have an auxiliary temp variable that takes, what you will do is you simply put I in temp and then put the last one. How can I represent the last one now? So in this case, it's n-1, but generally we want to represent this, right? Because it would be moving, and put it in I, and then finally put temp in this one that we didn't really decide yet, right? So this is the operation we want to achieve. I have I because this is what I'm moving on, right? But this one I left unknown because I'm starting from last and moving backward, right? And then multiple questions now. That's the first one. That's the second one. Where should I stop? And what should be my increment value? What do you think? First of all, do you see the methodology? In fact, we are thinking of a solution, we are architecting a solution without even writing a full C code or caring about syntax or anything. I'm just thinking what gets the algorithm to operate correctly, right? And what information do I need? And that what I have wrote here is just a pseudocode that exactly does what your friend suggested, right? So we just wrote our minds on a paper to better visualize it and see the open questions we have. So let's take them one by one. For the first open question, which is this question mark here, what should be the value? Well, if I'm not very sure, I would rather maybe start exercising with a couple of examples. So if I'm starting from I0, this is I0, this will be n-1. If this is I1, this will be n-1 minus 1. If this is I2, this will be n-1 minus 2. So how can I include that? n-1 minus I, exactly, thank you. Right? So if I write this like this, say n-1 minus I, then I should be good. Great. Is that clear? So why is n-1 minus I? Because, well, I'm starting from the last element and decreasing by 1. And I is my counter. So this is just like the intuition behind it. And I confirmed it with running a couple of examples, right? Great, that's the first question. The second question is, well, let's take the third one because the third one is easier. The third one is what is my step for I? 1, because I'm incrementing. Like I want to take the first element, put it in the last, and then go to the first, second element, which is 1, and put it to the second last, etc. So this means I plus plus. What about my exit condition? n-1 over 2. Okay, so you jump it directly to the conclusion. So let me take it step by step. If I'm thinking that my exit condition here is just n-1, similar to any array for loop that I have done before, what would happen? So if I have something like this, my exit condition is I less than n. What would happen? What do you think? Exactly, you will reverse it twice, which means it will just go back to the initial condition, right? Because what you will do is, well, your array is 2 halves. And what you are doing is, in fact, going through these two halves and replace them, swap them. If you continue doing this after really reaching your half, you will re-swap what you have swapped before, right? So maybe if it's not very clear, we will see it from the code. So let's write this kind of interesting example. Now I'm getting rid of, well, just write, this is solution 1. And I am, well, come on. Come on. Okay, so this is the first solution. So the second solution, I'm getting rid of the Y array. So in this case, we said we'll need a for loop. This for loop will start from 0. And let's say for now, I will just go through the full array and then increment. And here I need to define I. And we also needed a swap variable called temp. Maybe initialize to 0, doesn't matter. Oh, but this should be double. And what we said we will be doing is we will take temp to be equal to X array I, then overwrite X array I with the last element, which we said generally should be n minus 1 minus I, and then X array n minus 1 minus I would have taken the value of 10, right? So this is just a straightforward swap function, right? Yeah, are we good? So let's see if we have done this, what would happen then? Am I missing anything? I don't think so. So let's run and see. Well, after running it, if you observe, this is the exact initial order, right? And the reason is, as we have said, if you really go through your full array, you will swap the halves and then re-swap them back, right? So to address this problem, you need here a little bit more advanced condition, which stops I before doing the re-swapping, right? So this is more or less, you need to think about the corner case. But let's say, for example, we put n over 2. So in the case of an element or an array of 6 elements, I need to swap 0 with 5, 1 with 4, 2 with 3, and I'm done. Correct? Well, but that means I need to stop at 2. So n over 2 is, in my case, is 3 instead, right? So what I'm doing wrong is, in fact, you should stop at n minus 1 over 2. Because n minus 1 is your last element, which is 5. And then simply n minus 1 over 2 will be what? In our example of an array of 6 elements. N minus 1 will be 5. 5 over 2 will be 2. Exactly, thank you. This is an integer division, so it will be 2.5, but eventually it will be 2, right? So you'll be stopping at 2, but in this case, you must have an equality condition, right? What about the odd case? So we have to think about an array of size of 6 elements. What about an array of 5 elements? You will swap 0, yeah, please. Yeah, let's double check. Hopefully, let's see. So we have 5 elements, right? So from 0 to 4, 0 will be swapped by 4, 1 will be swapped by 3, and then 2. What will happen for 2? Well, 2 is your middle element. It shouldn't be swapped by anything. Just will stay in place. Correct? So this would be the case for an odd element array, a number of an array that has a number of odd elements. But let's see if my condition is satisfying it. So if I have n minus 1 over 2 again, n is 5 in my case, n minus 1 is what? 4. 4 over 2 is 2 still. So it will be an equality, which means you will do the swapping for the 2 case. But what would be the swapping thing? So n minus 1 minus I in this case would be 5 minus 1 is 4, minus 2 is 2. So in fact, what you are doing instead here is replacing 2 by itself, right? So you'll be swapping 2 to itself. So you're not really doing much, right? So it's just a wasted operation, which is okay, still functionally correct, right? I could have avoided it if I wanted, right? Maybe thinking a little bit more clear condition, but we can leave it as is for now. But you see basically how this solution is better than the solution if using another array, right? We didn't use another array. What additional memory did we use here? Well, we only used a double variable, which is 64-bit. Compare this to you are using an array of the same size, which might be millions of bytes of the memory if the array is very large, right? Just make sure this runs and we're not doing anything wrong. So let's see. So in this case, we see that the array has been reversed. Good. So another way of doing this is instead of using this complex condition, you can also say, well, instead, I'm defining another variable that is called j, right? So you can write something like, well, I'm having 2 pointers or 2 variables, 2 indices instead of 1. And then, well, let's in fact also discuss this solution a little bit in an algorithmic way. But is there any question here before I jump into a third solution? I will take the whole lecture for the example, but that's very, very important. I don't mind doing it. Because we have revisited almost all the rules we have seen in arrays, functions, variables, initializations, etc. So is that clear? Is there any question here? Yeah, well, that's also a good point. And I believe this was your friend point here, is that there were a couple of inefficiencies in this solution. One of them was the clear one, which is the space. But the second one was the running time. Because here in this case, I'm not really only going through the array fully, but I'm going through it twice, right? So if you want, and usually this is how people measure running time. If you have an array of n elements, you are generally having 2 n operations, right? Because every for loop is an n operation, which n iterations, right? One iteration could be multiple operations, but it's n, right? So here I have a 2n. Here, what do I have? N over 2, right? So here you are taking 4x the running time. This might not be very clear from an array of 6 elements, but if you have an array that has 10 million operations and it takes you 5 minutes to run it, well, cutting down the 5 minutes to a minute and a half makes sense. Cutting something from a day to like a couple of hours also makes sense, right? So you are correct. There was also here an inefficiency in the running time, and here it works better, right? Good? Okay. Yeah. Well, it's not n squared because it's not a nested loop, right? So think about this. What you do here is you go through your arrays n times, and you do some operations, right? But these operations are fixed at time, like just copy an element, put it here. And then after you finish the n, you take another n. So it's n plus n, which is 2n. If this was a nested loop, then it will be n iterations. Every iteration might take another n, so it's n squared, right? But here it's just a 2n, right? Good. Great. So if that's clear, then let's quickly look into what might be a third possible solution. Just add another slide, discard, and put it back. Okay, good. So in that case, I'm not going to algorithmically change the solution, but rather do it in a different way. So these are, again, my array of 6 elements. What I'm saying is I can clear my thought by thinking about the array has 2 indices, not just one. One starting from the beginning and one starting from the last, right? And then my problem right now reduces to, well, this swap operation should be between what and what? Simply I and j, right? So here, I should just say, well, there is a temp variable that has an array takes I, and then array I should really take array j, and then array j would take temp, right? Correct? But then now the problem goes to how should I define I and j, right? I is the one starting from 0. So it's a little bit clear. You really have I starting from 0, and then should I increment every time by 1. What about j? Yeah. Yeah, thank you. So simply it's the other way around, right? So this one will be traversing from here. Let's write this one here. This one will traverse in the opposite direction, right? So start from n minus 1, which is the last element in my array, and then reduce by 1 every time. Great. So I define my initial condition, which these two. I define my steps. When should I stop? Exactly. Thank you. Basically, when they meet, right? So when I and j meet, which usually is in the middle, this is where should I stop, right? So my exit condition should be I equal j. Please.
So what if like I and j are immediately beside each other? So I think the better condition would be I is smaller than or yeah. Like I is greater than or equal to j. That would be a safer condition, right? Just having them equal. But if you increment and decrement them at the same time, they might pass.
Yeah, okay, that's a good point. So I would say this is unlikely to happen, but you are correct in a sense because this is unlikely to happen because programming is really sequential. So they will not really increment and decrement simultaneously, right? But if you are implementing, for example, a hardware solution, and this is an algorithm for hardware that increment and decrement two counters independently in 2DI, for example, then you are correct. Then in fact, you should really guard against the case that both change at the same time simultaneously, and then put a condition like this. That's also, but you want it to be larger than or equal, right? Because this is the time where I might exceed it, right? So that's also correct. So thinking about this kind of a draft algorithm, I have initial conditions, I have a step, and I have an exit condition that is dependent on two variables. Maybe in that case, using while is better than using for, right? Because the condition now became a little bit complex. So we should be implementing this using while instead, right? Oh, if I refresh you, I lose my solutions. Okay, good. So this is the second solution. So for the third solution, well, we said right now we need I and j. Well, but in fact, I can also initialize them in the same declaration statement by setting I to 0 and by setting j to n minus 1, which is my last element, right? By the way, one question to you. How am I using n right now as a variable without really defining it inside the function itself? Yeah, because this is an input parameter, right? Yeah, so input parameters are also defined as local parameters to this function. So it's just, this is why it's okay to use the input parameters as is, right? You don't need to define them. Great, so I initialized my two variables. And then I would write my while loop based on the exit condition that I is larger than or equal to j. And then what did we say we should do? In fact, we should have a double temp. Well, plus 0 doesn't again matter. And then say that temp equal x array I, and then x array j would be x array I, and then x, oh, I did something wrong here. It should be I, should be j. And then x, array j should be equal to the temp, right? Great. And by doing this, well, I should be all good. I'm missing one thing here. What I'm missing? Yeah, your step function. Otherwise, you would have an infinite loop, right? Because in that case, always I would remain 0, j would remain n minus 1, and the condition will always be true, right?
You need to like
Exactly. Yeah, that's also your exit condition, right? So this is your exit condition. But let's first address the point that we have raised earlier. So it's I plus plus and j minus minus, right? So this is basically your step. And the second point that your friend here highlighted is that this is in fact should be your exit condition. But what you write inside a while is not your exit condition, is your continue condition, right? So it should be the not of this. Or in other words, as far as I remains less than j, I should be good, right? Great. So if I do this and run, well, I end up having them reversed. Good. So a couple of last questions. Is solution 3 better or solution 2? What do you think? Please. Exactly. Thank you. So the point that I should ask myself better in what perspective, right? So here, given that we discussed, please. Yeah, well, that's also a good point, but that's a very increment. Yeah, well, if you want really to count, you want to count all the variables, how many bytes you take, which is an exercise you can do. In that case, you are defining a new j, which you don't have here, which basically will take, well, 32 bits. But that's really very, very incremental. It's not a big deal. But in the general scheme of things, thinking about an array that has million elements, which is usually the case, then it wouldn't really matter to have another variable. So they will be, well, almost the same, correct? Both from the space and runtime efficiency. Great. So basically, there are two different solutions to the same problem, but just thinking about it in a different way, right? The algorithm itself is almost the same, but just coding it differently. Great. So the last thing is, you might have observed that this is a typical function, what we usually call in programming or software engineering a utility function, something that maybe you need in other programs as well, which is swapping, right? So you can also think of, I can really take this piece of code and instead write a function that says swap, and then you swap the two variables, right? And well, simply because I need to swap now, so I need to pass them by reference. So I need to swap what variables? I need to swap AI and AJ, right? But you didn't really learn yet how to write a function that passed things by reference, like using pointers, etc. So I would just leave it as is, but we'll revisit it later when we come to pointers. Good? Is there any question? So we took the whole lecture for one example program, but hopefully it's worth it. Thanks everyone, and you have questions, please come by. Yep.
Can you upload that example?
Yeah, I will upload it as well. Yeah, thanks.
I'd like to ask you when your office hours are. I tried to look it up and haven't.